Hello, hello, hello. So I hope I'm audible and visible. Okay. So in today's class, okay. Hopefully my screen is visible. Sorry if I have little fever. So let's begin the class. Today we are going to solve few questions. These are the questions I've selected. Before solving the questions, let me give you a quick recall. All right. For example, if this is the container and let's say I want to calculate the pressure at this point, which is H below at a certain depth. So what are we going to do? Let's say the atmospheric pressure at the top is P naught. So total, okay, my handwriting is getting worse day by day. Total pressure is equals to pressure at the top, which is P naught, plus pressure due to this much of liquid. Okay, pressure due to this much of liquid. So that will be equal to rho. Rho is the density of this liquid, G is gravitation, and H is the height or the depth which we are going in, right? Okay, so hopefully this topic is clear to you all, right? Okay, what if I want to calculate pressure at an adjacent point, same height but slightly on the right, let's say at distance d, let's say, then this pressure will also be the same. For for same level, the pressure only depends on the change in pressure only depends on the height. So if we are moving horizontally, the change in pressure will be zero, right? Okay. So what if I ask P1 at this point the pressure is P1, at this point the pressure is P2, find the ratio between P1 and P2. Then the ratio between P1 and P2 will be 1:1, since the pressure will be same at both the points, right? Okay. Hopefully this recall is clear to you all. Now, okay, one more thing, one last thing. This term, this rho GH term, this term is called, let me write it down. Individually, this term is called um, gauge pressure. So if I want to calculate gauge pressure, you just have to calculate the pressure due to the liquid above, nothing else. All right. Hopefully this is clear. What is gauge pressure? The pressure due to what do you say? Only the liquid, not the external pressure, right? Due to the atmosphere. Okay, I'm giving you 5 minutes to solve this question, right? I'll explain you the question first. For the arrangement shown in the figure, what is the density of oil? You have to calculate the density of the oil. All right. So if I say to you, I'm giving you a hint, the pressure at this point and pressure at this point will be equal, right? Same horizontal level. Just equate these two pressures, you'll get your answer. Come on, try it. Try it. Try this question. Try this question, guys. It's an important question to build up the basics. Okay. Just equate the pressure at these 2 points, point A and point B. Just nothing else. Just try it for yourselves. Pretty simple question. Whatever whatever we've seen in the recall, just you have to apply that, nothing else. Just try it. Okay, let me solve this question. So see, I'm taking only this portion, all right? I'm taking this part, only this part. Can I say this part is equivalent to what we have seen in the, what do you say, what we have seen in the recall, right? We can say that, right? Now, what I'm going to do is, so what is the atmospheric pressure here? Let's say it is P naught. So for left, I'm applying, for left, I'm calculating PA at point A pressure. So P naught plus rho. What is, sorry, pressure due to this depth will be rho of oil into G into height. This height is D, right? For right, what I'm going to do is P of B will be equal to P naught plus rho of water into G into D. What is the depth here? It is L, means L, right? Okay. What I'm going to do is I'm going to equate these two because on same horizontal level, the pressure will be same, right? Pressure at A will be equal to pressure at B. As simple as that. Just apply it. Pressure at A is equals to P naught plus rho of oil into G into height of oil was D, right? P naught plus rho of water into G into L. Now, this P naught and P naught will cancel out. What will rho of oil into G into D will be equal to rho of water into G into L. So we can cancel out G as well, right? To substitute the value, we have to calculate rho of oil, means the density of oil, right? In the given question. Then D. What is D? What is D? D is 12.3 millimeters. You don't have to convert it because ultimately both the sides are going to cancel out. What is rho of W? The water is 1000 into length. What is L? L is given as 135 millimeters. 135. Just solve it, you'll get your answer. What will we get after solving? 1000 into 135 divided by 12.3. I'm just removing this point. So this will give us 10 to the power 4 into 135 divided by 123. What is 123? Okay. What will we get after this? That will be 1.75. 75 is 12. 1.1 something, right? 1.1 into 10 to the power 4 kg per meter cube. So this is your answer. Hopefully this is clear to you all, right? Come on, note it down. Note it down, guys. Hopefully this question is clear. What we had to do, we just had to equate the, what do you say, pressure at same horizontal level. Now you might think how to choose the same horizontal level. What you can do is you can just, what is the other medium which has been added? For in this case, for example, the oil has been added, right? See, The oil has been added. So where does the oil and water has the interface? You just have to take that interface and just take that as the horizontal level. All right. Okay. Next question I'm giving you. Just try this question. Try this question. Try this question, guys. Try this question, guys. Three more minutes, guys. Right. Let me give you a hint for the time being. Take these two horizontal levels, right? And let's say this is A and let's say this is B. Pressure at A will be equal to pressure at B. I've given you the hint right now. Okay, it's my turn now. A YouTube of uniform. It's not that YouTube, just to be clear. Very bad joke. A YouTube of uniform cross-sectional area and opening to the atmosphere is partially filled with mercury. Okay, it is filled with mercury. Water is then poured both arms, means both the side water is poured. See, I'm coloring water with blue. The dotted one is given as water. If the equilibrium configuration of the tube is as shown with the H2 equals to this, find the value of H1. We have been given the value of H2, right? It is 1 centimeter. We have to calculate the value of H1. Okay. Since the middle part is not been given, we are considering this as, let's say, H. Okay. Hopefully I'm audible and visible, right? Okay. So at A, pressure at A will be equal to atmospheric pressure P plus rho of what is this? Water, right? Plus total depth that will be equal to H1 plus H plus H2, which will be equal to okay. Hopefully my screen I'm audible and visible now. For some reason my internet got stuck. Okay. Okay. So where were we? We were at this point, right? Yeah, at point B, P naught plus rho of water into this height H plus rho of mercury Hg into what do you say? Um, this height H2. Okay, to substitute these values, since these two will be equal, right? P naught will get cancelled out. P naught and P naught will get cancelled out, and just substitute this value, you'll get your answer. Okay, let me solve it. Rho of W into H1 plus rho of W into H plus rho of W into H2, which will be equal to rho of W into H plus rho of Hg into H2. So again, rho of W into H, rho W into H gets cancelled out. See, we know these values. We know H. We have to find H1. We know rho W 1000. We know rho W. We know rho Hg. I'll tell you, and we know H2. You just have to solve it, right? Let me just tell you the value of rho H2. You can solve it, right? Till then, try this question. Try the value of rho Hg. Okay, a rho of Hg is equal to, I'm writing it down. They should have mentioned here though, but just memorize it. Rho of Hg is equals to 13.6, right? Just note it down, guys. Note it down. And by the way, this is in centimeter, sorry, gram per centimeter cube. If you want to convert it into, just multiply by 10 to the power 3. Just solve it, you'll get your answer. Right? So, here, right? Rho of water in CGS unit is given as 1 gram per centimeter cube. Rho of Hg in CGS is given as 13.6 gram per centimeter cube. Try this question. Try it, guys. My Okay. Hopefully, my screen is visible. Let me take this question. All right. A U-shaped tube open to the air at both ends contain some mercury. Okay. Quantity of water is carefully poured into the left arm of the U-shape until the vertical height of the water column is 15 centimeter. Water is filled at 15 centimeter height. What is the gauge pressure at the water mercury interface? Means we have to calculate the gauge pressure. What is gauge pressure? I told you in the beginning in the recall time. We saw that gauge pressure is just exclude the atmospheric pressure due to the liquid itself. That is called gauge pressure. So let me solve the first part. The first part, gauge pressure, let's say it is P is equals to rho of what it's water, right? Water into G into height. That height is 15 centimeter. Just convert it into meters, divide by 100. So this will give us 1000 into 10. Let me take that value as 10. Value of G 100 zeros and two zeros will get cancelled out. 1, 2. So 1.5 into 10 to the power 3. Hopefully this is clear, right? Gauge pressure, and this will be in Pascal. So hopefully the first part is clear. Now we have to calculate the second part. Calculate the vertical distance h um, from the top of the mercury in the right hand arm of the tube to the top of the water in the left hand. Means we have to calculate this value, this h, right? Okay, where we have to take what we have to do, we have to just, I'll take this interface, right? At A and at B. I'll equate the pressures at A and B. The second part, I'm writing below here. Pressure at A will be equal to P naught plus rho of water into G into height H, which is 15 by 100 centimeter, which will be equal to B. Pressure at B, that is P naught plus um you have to calculate the value of H, right? Um at this point, let me see. Point B. I'm messing up something. Let me just check the solution of it. Just give me a sec, guys. Question 16.4. Yeah. Yeah, got it. So P naught at this point, we have to calculate the pressure, right? So P naught plus what pressure due to this mercury part, this one. I'm shading it blue, that part, that will be equal to rho of mercury into G into this length. Can I say this length is 15 minus H, right? 15 minus H. Just substitute all the values, you'll get your answer. P naught and P naught will get cancelled out. Rho of water is 1000 into G is 10 into 15 by 100, which will be equal to rho of Hg is 13.6 into 10 to the power 3 into 10 into 15 minus H. So I think certain things are going to cancel out. 1000 and this 1000 will get cancelled out. G and G will get cancelled out. And just taking 13.6 down, 15 by 100 into 13.6. Sorry, not into, into 13.6, right? After that, either 15 plus H will be remaining. So what will we get? Let me solve it. H will be equal to 15 minus 15 by 100, 36. So we'll get answer. It's pretty easy to solve. You can solve it easily. The answer will come out to be okay. I don't know what is happening today, but internet is fluctuating a lot. Hopefully, I'm visible and the screen is also visible. Solve this question. I'm giving you 5 minutes to solve this question. We already solved this question in the previous class. I think you'll have a good idea of solving this question now. So try to solve this. Solve this question, guys. It's a good question. Solve it, guys. 3 more minutes. Right, guys? Try the question. Okay, let me solve this question now. For the system shown in figure, the cylinder on the left at L has mass 600 kg and a cross-sectional area means here the mass is 600 kg and the area is 800 centimeter square, right? And after that, the piston on the right at S has cross-sectional area 25 centimeters square and negligible weight. If the apparatus is filled with oil, what is the force F required to hold the system in equilibrium? So pressure at this point will be equal to pressure at this point, right? Pressure at A will be equal to pressure at B, right? So we just have to solve this. Pressure at A will be external pressure, atmospheric pressure P naught. Now I think it's given to you that P naught ultimately gets cancelled out. So we just have to take the gauge pressure, right? Hopefully this is clear to you all. Take the gauge pressure, that will be equal to pressure at this point, that is force by area. Area is 25. 1 meter is equals to 100 centimeter, right? So 1 meter square will be equal to 10 to the power 4 centimeter square. So if I have to convert centimeter square into meter square, I just have to multiply by 10 to the power minus 4 plus rho gh. I'm going at a depth, right? So rho of oil into g into height. What is the height? 8 meters, which is equals to pressure at this point, that is equals to force, that is 600 into 10 mg. The force is mg by area, that is 800 into 10 to the power minus. You just have to solve this question. Okay. Now you just have to calculate the value of rho naught, right? Sorry, not rho naught. You just have to calculate the value of what exactly? Everything is given, right? We just have to calculate the value of force F. Rho naught is given, G we know. Just solve this, you'll get your answer. Let me solve it for you guys. F upon 25 into 10 to the power minus 4, which is equals to 2 zeros and 1 zero will get, these two will get cancelled out. So 60 into 10 to the power 4 divided by 8 minus into 10 to the power 4 minus rho naught is 0.78 into 10 to the power 3 into G is 10 into 8. So 10 to the power 4 will get, common. We are left with 60 by 8 minus 0.78 into 8. To solve this, you'll get your answer. F upon 25 into 10 to the power minus 4. So this will basically become 10 to the power plus 4 divided by 25, which is equals to 10 to the power 4. 60 by 8 minus 0.78 into 8. 10 to the power 4, 10 to the power 4 will get cancelled out, and you can easily find the value of what we say F, right? Try to solve this question. Try to solve this question. I'm giving you 5 minutes to solve this question, okay? Solve this question, guys. It's pretty important. Okay, guys, let me solve this question. Water and oil are poured into two limbs of a U-tube containing mercury. Okay. The interface of the mercury and the liquids are at the same height, means these 2 points are at the same height, means one interface is here, one interface. What is interface? Interface just simply means where oil and water basically meet. Okay. The interface of mercury and the liquid are at the same height in both the limbs. Determine the height of the water column H1. We have to calculate H1. If that oil H2 is 20 centimeter, the density of the oil is this. What you have to remember, okay, I'll tell you another way to solve these type of questions. Okay, first, it's pretty pressure at A will be equal to pressure at B, right? A is here, B is here. As simple as that. Now what we can do is, see, point 0.9, if this is given, means this is given in gram per centimeter cube. Means basically it's given in, what do you say? Um, it's given in CGS unit, right? Everything is given in CGS, means centimeter, this and this. What you can do is rho of mercury. Rho of mercury, we know 13.6 gram per centimeter cube. And the value of G will be equal to 10 to the power 3 centimeter per second square. Just remember this. Using CGS system, we are going to solve this question. Okay. This will be equal to rho of mercury into G into height H1 will be equal to rho of mercury into G into height H2. So what we are left with, okay, everything will get cancelled out. Rho of Hg, rho of G, rho of Hg, rho of G, height 1 will be equal to height 2. That means it is equal to 20 centimeter. Hopefully this is clear to you all. Just note it down. It's a good question. Just note it down. We could have also solved this question using basic logic. Okay. Okay, if you pour same substances and they are at the same length, then the height reached would also be the same, right? This is the last question of today. Try to solve this. Try to solve this question. 5 minutes. Try to solve it, guys. Okay, let me solve this question. We know pressure at point A will be equal to pressure at point B, right? Pressure at point A will be equal to rho, that is water. So rho of water into G into height H will be equal to rho of what is that? Mercury into G into H is 2 centimeters. We are going to solve it using CGS unit. The G and G will get cancelled out. Rho of water in CGS is 1. Height H we have to calculate. This is 13.6 into 2. So H will be equal to 13.6 into 2. That will be equal to, let me solve it. 6 to the 12, 3 to the 6, 7, 2 1 the 2. 27.2 centimeter. Hopefully this question is clear to you all, right? So just try some more questions related to this same topic. Okay, the U shape. These are very common topics which comes a lot in exams. So hopefully it is clear to you all. Meet you guys in the next class.